Good morning. All right, so now we're pumped. Welcome to our first session. We have a few sessions today focused on AI. Today, the first session is accelerating autonomy through AI, and especially around humanoids and augmented humans. My name is Nilofer Sadie, and on the stage with us today, we have Mr. Young Bang. Young is the Principal Deputy for the Assistant Secretary of the Army in Acquisitions, Logistics, and Technology. We've got Mr. Stephen Bathish. Stevie is the Technical Fellow at Microsoft and Corporate VP, and he heads up AI for Windows and devices. And then we have Colonel Autonomy. Troy is our Director of Integration at AFC Army Futures Command right here in Austin. So welcome, guys. Troy, we're going to start with you. Can you share with us a little bit about how the Army prioritizes and thinks about AI, humans and machines teaming, and especially augmented humans and humanoids?
Is this working? Okay. That was the first mic check. So good morning. Thanks for coming today. It's a privilege to be on this panel and talk about how within AFC and arguably broader across the Army, how we're thinking about augmented humans, and I'm going to talk about what that means to me, and AI today and going into the future. So first, just to kind of set some ground rules or context, Army Futures Command, we are largely thinking about the time span between 2030 and 2040. And with that, you can't think about 2030 to 2040 without understanding where we are today and understanding what that roadmap may lead to. But to go to your question on augmented humans, so what I would say that means is how are we able to partner or integrate robots or other machines with humans so that we optimize what robots or machines are good at while still optimizing what humans are good at. Just to give a couple examples of what that would mean for us is, I think the days of a machine being able to understand ethics is a long way away. And your Army is a value-based Army. So a machine's not gonna get there. That's why we still need humans to participate in whatever endeavor we go down with this teaming. I would also argue that teaming is also a human endeavor, so it's probably more of an integration of how do we take machines and integrate them with humans in a meaningful way. And then there's things that machines are really good at, and we ought to optimize our thinking and our plans towards that. And that is how we are like bracketing the work that we're doing while understanding some of the limitations of where we are today while envisioning the future.
Thank you. Stevie, with what you just heard, can you share with us a little bit about how that may be aligned with or differ from how industry looks at it and prioritizes?
Thank you. And again, thank you for inviting me here on the panel. I'm honored to be next to you folks. A lot of what we focus on is trying to invent the next computing form factor. And so if you look actually over time in history, computers have gone through very, very large, difficult to use devices that really highly specialized people could only use. And their functionality and adaptability was quite limited. Over time, you can see basically computers starting to diversify and even more specialize to help solve problems and help people essentially solve problems. And today is no different as we have a rapid innovation, a rapid pace, and computers continuing to essentially change their form, change how they're looking, go into different places that we're typically not used to, and it's really as a result of kind of a three-factor trend. One is, at every new computing form factor stage, you've seen a massive step function in compute availability. And with that compute availability, you have the ability to write more complex software that helps abstract the functionality of that computer. and that also improves the interaction of that computer with the human. And the more natural you can create that interaction with the computer, the more seamless and more powerful that tool becomes, the more available it can become, and the more diverse you can put it in sort of different locations. And you can see that trend all the way from mainframes to desktop computers to laptops to tablets, phones, wearables, even today. And you can now even see things like devices becoming more diversified, like ambient computing, stationary pucks, for example, et cetera. Each one demanding more compute and a more natural, intuitive interface.
Awesome. Young, based on all of this, can you tell us some of the things, some of the considerations that we all need to take into account when we're talking about implementing AI, especially around risk and security?
Yeah, thanks, Nilly. So thank you all for coming. I know it's early for a South by. Y'all were probably out on 6th Street or Congress all night, but I appreciate y'all coming in early with the coffee in hand. And I really want to have much more of a dialogue here too, and hopefully it's also with the audience as well. But going back to what you said is maybe just a step back. People, well, Nilly said my title, and it's pretty long, and people are like, "What is that?" So if y'all understand industry, the equivalent is that our office is responsible for all technology. And so if you think about if we buy it, if we develop it, or if we integrate it, that comes out of our shop. And the other thing is the chief scientist, chief engineer, chief technology, or the equivalents of those officers are actually from our office. And so if you think about whether software, cyber, data, AI, whatever that you think about, that really is where our office kind of sets where the investments will be from a S&T and R&D working with our colleagues at AFC, and then where we actually build or buy or develop so we can send it to our soldiers so they can do their mission or protect their lives. And so when I look at that, people are like, well, that's a lot. But I always say, I look at myself as probably the Army's biggest Scrum Master. And the thing that I do is, just like a good Scrum Master, you have good folks on your Scrum teams that really kind of get the work done and work your backlog. My job, I think, is to really look at the enterprise obstacles, right? So if you're a Scrum Master, you look at what are the obstacles I'm going to just take down so my team can actually go ahead and really drive through the velocity. And so for us on that side, y'all probably heard this Saturday, our secretary kind of announced the whole software directive. That was a culmination of a lot of work for us that we've been embarking on for the past year and a half or so. But that's so we can actually just kind of catch up to what industry is already doing, right? So modern software development. And I say that because there were a lot of enterprise obstacles that prevented us from getting there. So hopefully this helps really codify that process that y'all already do in industry. And that's important because if you look at software and data, right, you have to, Stevie talked about abstractions, right? What we're looking on doing is creating abstractions from hardware, software, and data. And I say that because data is a prerequisite if you want to get AI at scale. You got to clean up that mess from a data perspective, and to do that, you have to decouple that from the software. And you have to decouple the software that tightly couples with your hardware, right? So we're trying to develop everything as abstractions across the board. And because the need of having data to enable you to do all those things gets you to the AI scales. We're doing AI already, but it's not at scale, it's in pockets. And same thing, I'm looking at how do we really break down those obstacles so we could get AI at scale and adopt third-party generated algorithms. I really love what Stevie talked about, really kind of the form factor and how we actually interact. And Troy talked about whether it's technology or humans or teaming, right? How we interact with technology has evolved. And I really love the notion of the technology evolution that Stevie talked about, right? Because we can do so much now with processing and storage, right? And the compute components, right? That's kind of ubiquitous, and it's really table stakes from a digital native perspective. And I think the way that we've been looking at, so I'm old school, I learned how to code, right, hard coding things. My kids, when they were 5, learned how to program using Scratch, right? That's how our interfaces with technologies evolved, right? So the old dinosaurs like me that can just knock out code, right? okay, we're probably passe because the way that we're going to interact with technology to include AI and data has to evolve with it. And so I think that what we're trying to do is look at that paradigm a little bit differently and making it easy for our users, our soldiers, our analysts to do basic things like visualizations, querying, so they don't actually have to know scripting, right? We want to enable them to do certain things from a data perspective as well as on the journey to algorithms and eventually to AI. And I say that also to Nili's point about, there are some obstacles there. And so just like from a software perspective, I'm trying to knock out these enterprise obstacles. We're trying to do that with data and AI. And I say that because we want to be one of the early adopters for all the cool algorithms that industry is developing. And we want to enable that for our soldiers. But I feel like there's a couple prerequisites that I have to think through for the Army so we can actually accelerate the adoption of third-party generated algorithms. And part of that is we have to look at it from a risk perspective and a cyber risk perspective, right? And how can we, so I think we all have a pretty technical background, and y'all probably know it too. If you compile open data sources, right, and you use it for computer vision algorithms, it's already poisoned, right? The open data sets that are out there are poisoned. And we're not saying we want to reduce everything because we all know we can't. So what we're trying to do is saying we want to create a risk framework that enables us to identify where the risks are, and based on the mission, make those risk-based decisions just like industry does to say we're going to employ in this scenario. Maybe it's a closed system, or in this scenario, maybe it's for our business systems. But if it's for something that touches our warfighter and safety and lives are considered, then we want to really nail down all the risk as much as possible and then still make a risk-based decision. So we're working on something like that. Y'all will probably hear more about that, but it's really identifying a risk framework so we can actually adopt third-party generated algorithms that y'all have, right, at scale.
Can I jump on something there too? I think what Mr. Bang was talking about too, from an enterprise perspective and setting, well, I'll just say some ground rules and a way to participate with industry on this journey. One of the things that the Army is starting to come to grips with, and it's taken us some time, and I've been on this journey for probably about 7 years now, as a lot of the systems shown in that video I used to manage. Early on, I would talk to folks, leaders in the Army, and they'd tell me, hey, Troy, I want some AI. Go do some AI stuff for me. And I was like, cool. Can you define the problem we're trying to solve with AI? So there's been a learning that's occurred across the Army at all levels of, hey, AI is not a panacea, and it's a tool, but how we implement that tool and where are we with the tech tree to get to that is also important, and making sure that we are honest with ourselves of where we are just from a technology perspective, what we can implement today and where we want to go in the future. So it's been a bit of a journey. So, and this is kind of, with the software policy that was just signed out is kind of indicative of the maturity of the Army around this effort.
Yeah, so give me some of that fairy dust and make everything happen magically, right?
I know you have something to add here.
Oh, I mean, yeah, there's several, both of you mentioned, that popped to mind. Let's see if, I think to the point about abstraction, absolutely. I think, compute and software allows us, for the most part, to abstract out the kind of the core functionality. And I was trying to think of like an analogy here that maybe folks can relate to. It's, I don't know if you remember like how you used to use your remote control for your television and the VCR. And you wanted to, record something or watch TV, you have to go through the remote and like click all the buttons, say, okay, switch it into VCR mode, hit the play, go to TV, do that, go to the satellite button, like do that. And then somebody smart came along and said, I want to invent a smart remote. Instead of having it be so programmatic, so explicit on what I wanted to do, like literally programming your devices. That's really what you're doing. You're programming your devices, and we give that's a consumer product. It's like, you know what? I just want to watch TV, or I want to record a thing, make it a high-level task. And what happened is the software up there on the remote took that, and the smart developer abstracted the functionality of those components and took and enabled a interaction technology, an interface that says, instead of it being like very like device-based, it's going to be task-based. What do you want to do? I want to watch TV. Click that watch TV button, and then the remote control took care of all the low-level details. So you take that analogy and basically like apply it now to everything that we do in computing, and it kind of follows the similar sort of trend. It's kind of amazing to me to think about, like, we've been on this, interaction paradigm for computers. It's the same one for the past 5 decades. There was an amazing demo called The Mother of All Demos by Douglas Engelbart. Does anyone recall that? Yeah, it's pretty cool, right? Amazing demo to go back and watch. And just, you sit there and you're like, oh my goodness, I can't believe this was shown so long ago. And it's basically what we still do today. We point and click and we type with our computers. And over time, we made that better with compute. But today, we have such amazing amount of compute, such amazing amount of software and algorithms that allow us to go from something that was so explicit, where you literally had to click on the pixel, and I didn't mean to click on that pixel, I meant to click on this pixel. And it's more like to the generalities. No, I want to create a Word document. Or I want to create a new pie chart. Please create a new pie chart for me. You can do that today, right? Where before you were like, you had to go in there, okay, what do I need? I need to open up Excel. I need to put in the data. I need to do this. Like, now you can go to the computer and say, you see that column? Make that a pie chart. And that's kind of the same analogy of like remote control programming to just task-based. Tell me what you want, and I'll try to figure it out for you.
I love that. I'm going to double tap on that. So like that remote control example, like, I still help my mother-in-law, right? She's got the 4 remote controls, one for the TV, one for the cable box, one for the streaming, and one for, like, if I have to say, like, DVD player, right? And you're like, oh my God, it's a nightmare, right? And it's exactly what you said. Now we've converged that from a technology and a standards perspective, and now we've evolved that to like, kind of like your, remember the old iPods, right? The controls now, right? It's voice activated, as well as you just kind of use your thumbs now instead of all the buttons. And so in the future, we were talking a little bit about this yesterday, right? It should be a little bit more abstracted from even that, and regardless of the platform, because we have ubiquitous storage and compute, it's in the cloud, but then we can actually use that and do voice interactions, right? So those voice interactions can be NLP, text conversions, all those type of things to do commands, so you don't actually physically have to touch the remote in the future. And those things are what industry is working on now from a consumer perspective, but what we need help from industry is take that tech and apply it to us and our soldiers, because right now, that analogy of 4 remote controls, guess what? Our soldiers do that with 4 vertically integrated stovepipe silo systems. In fact, if you go to like those tents where they're at, it's more than 4, literally, right? And so there's the opportunity to converge the tech, to modernize it, to transform it to the future. So instead of going stepwise, let's jump to what the industry's working on, right? Whether it's voice commanded or whatever, but really make it much more intuitive for the user, just like y'all are doing for consumers. But do that with the soldier in mind to make it that much easier, so they don't have to hard code the code or the prompts, or make it descriptive, right? Or go to remote controls. Let's just leap ahead and help our soldiers make things and lives a lot easier.
Exactly. We went from punch cards to point and click to now just, tell me what you want.
Yeah, and I think there's a couple things on this too. Sorry, you're not going to ask any questions. We're having a good time. I don't know.
Okay.
If you
I
are.
saw what was happening
We are.
yesterday. I'm going to go sit down.
Yeah. The 2 things that come to mind on this. One is, we recently did a demonstration of some robotic capability that, and we're doing another demonstration in a couple weeks. But this was back in the fall, and one of the things that boggled my mind as we compiled this formation together of robots with a Army platoon was the leaders in that platoon had about 27 different remotes hanging off their neck trying to control individual robots. That is clearly not going to work. So how do we go from one person controlling one robot or machine, right, to one person controlling many? Huge effort, and something that we've got to solve within the Army. And then if just to also piggyback on another thought, if we think about where the Army's been from a compute and store perspective and that interface with that product, if you will, we went from being computer-based, then we got really, really fancy with laptops, some of them not very good laptops, but laptops. Then we thought we were real fancy. I don't have my phone with me, but we got, we can use commercially available phones. We had to change the name of it and call it, and develop an acronym, so we called it an EUD, so end user device, but a phone that we could load some software on to help us understand the environment. Situational awareness is the buzzword that we use. To now, where with the phone, I had to take my eyes down to see what was going on, and I wasn't paying attention to my environment. To now, basically face computing with that other product in there of the form factor, the compute's advanced such a way that now I can, with my head up, do the same interaction and get the same information and still be participating with the environment and not being at risk. And that's just been over those last couple examples over the last like 5-7 years that we've been able to advance that. So if you take that and then think to the future, the near future, it's pretty exciting, while still understanding that there's some challenges that we have in front of us.
Yeah, I love that. Like, so remember, I don't know, 5-10 years ago when those heads-up displays on the car, so you don't have to look down, you see your speed limit going or turn right or whatever on your GPS. Now they're working on glasses, right? Or, that kind of does the whole thing, or like for runners where it kind of, while you're running, or swimmers, right, kind of their goggles, that kind of flashes their lap times and stuff like that. That's what we're talking about. Those type of cool things that, industry is working on, that's how we can augment our humans to enable them to do things so they're not literally looking at 4 or 5 different remote controls, or in, the scenario that Troy said, all these controllers for separate drones, right? Right? And so how do we converge that and look at it from an augmented standpoint to really go back to what Stevie said? Let's automate a lot of these menial tasks that are really repetitive in nature, and then let people do kind of the higher order tasks until we get advancements in AI, right? To really closer to AGI, where we can really talk about the humanoid nature and those type of things.
And just one last thought on that too. Somebody that we work with fairly regularly, way smarter than me, a guy by the name of Dr. Ambrose, so I'm going to give him credit to this. One of the principles he talks to me about all the time is, hey, make sure the robot is working for the human, and the human is not working for the robot, right? And what I just described with the multiple controllers, arguably humans are working for the robots, so we've got to invert that.
So on that note, Troy, if you can share with us some of the examples, I know we saw some of them on the video, but some of the examples that soldiers have the capabilities today from an AI perspective, and then maybe we can talk a little bit about some of the testing and the way to test, considering what we've got today, and that already includes AI, but then also that could more quickly include AI, and how to consider doing that.
That is not a small question. So the way I think I'm going to choose to answer this is what we learned, and arguably across the Army here recently with some of the modernization efforts that we embarked on 5-6 years ago. And it's obvious, but stating out loud is therapeutic, so bear with me, is ensuring that the end user is involved in the process. So we established, and it's kind of pervasive throughout the Army, a concept called soldier-centered design. And it's based off a human-centered design that frankly we stole from Microsoft, right? So I'm giving them credit too, and we just put soldier in front of it. But involving the soldier at the onset as early as possible to help with the design of the product. And it doesn't matter if it's hardware or software. Because if you don't have the end user in mind right up front, you're probably going to deliver something that is going to be unsatisfactory at the end. So that was one of the big lessons that we've learned, and we've incorporated really throughout the Army's programs, many of them, almost all of them at this point. The other thing is, how do we assemble more than just a small team to assist with the design? It's really fallen agile and DevSecOps kind of methodology as well. But certain testing events over time that involve soldiers, we call them soldier touch points. And right now, if you don't have a soldier touch point on your chart in the Pentagon, on your program, you're going to get a no-go, and you're going to get sent back to go to start over. But how do you bring those in early to continue that iteration and learning over time, and really mature the product that way? So not necessarily formalized if in that aspect, but it's the process and the thinking to build that into the plan to continue to mature the product. I think the other thing is recognizing that the performance of said device, said software, it will continue to grow over time, and making sure that you understand what that looks like and manage it appropriately. You asked about 4 more questions in there, and I've lost them, so I'm going to pause.
Well,
for a
in
second.
particular, like I said, what showed up in the video, there are a lot of soldier capabilities that do exist today. So we're not necessarily starting from scratch, right? Do you want to share a little bit about what some of those capabilities are that either use or could start using some of those?
Yeah, there was, in that video you saw at least 3 products that I used to manage, and then I got fired from that job and sent here, but really wasn't fired. But it sounded really bad, and this is being recorded. The first one was the end user device that I mentioned. So it is a phone. It's got compute, right? There are some tasks that you can do more on the automation side that we started doing, or from to take some of the analysis that the user would need to do and automate it, right? To provide them options quickly. The second one was it was hard to see in the video, but it was a nano drone. Weighs a few ounces, has a little bit of software on it and compute on it. Well, we were able to take that drone with the phone, and the other system was IVAS, which was the heads-up display that you saw later in the video, and tie the drone into those different compute devices. So then we built some AI capabilities to allow that drone to do tasks with a simple intent order, like go recon a spot 500 meters from me, see if there's anything there. If there is, send an image back. So fairly simple, not splitting the atom, but pretty advanced to do kind of internally to those programs while taking advantage of the onboard compute that was available.
I can add to a little bit Colonel Denomy's, especially your first point on soldier-centered design. So I'm working on developing products at Microsoft for 2.5 decades, and a lot of product design and innovation really can be summed up in one simple phrase. It's all about managing complexity and moving complexity around so that it's in the optimal location. And in the human-centered design or soldier-centered design, it's really a lens of, I want to move complexity from the person down to the system. Again, to the akin of like managing the multiple remote control devices. And one of the important things, you kind of mentioned it, like when we were working as a team to try to solve a problem, it's really important to look at it holistically and bring in as many components and many parts of the stack as possible. Because when you're able to look at the problem holistically, all the way from user, all the way down to the lowest layers in the system, you can choose to essentially move the complexity around to the different systems or identify opportunities of innovation where you want to put that complexity essentially in there. And that's how you can develop the best product at the time. That's how we did it with when we developed Surface. That's how we developed when we worked on HoloLens.
Yeah, that's awesome. And as you think about these things, you think about the risk, the different ways that you want to look at risk. How about the way you would test these capabilities as you implement that?
Yeah, I was going to jump on that since y'all covered a lot of that. There was a lot in there, so the test part, I don't think we touched, but I think this is important, and this is where we really need the big brains y'all have out here. If you think about when I talked about the abstractions, right, it was purposeful for multiple reasons. One of them is, like, we were actually discussing a little bit of this yesterday with Stevie. If you look at software, it's all deterministic, right? So I might write code to say, hey, describe this, yellow sticky notepad, right? And I might make X amounts of code, the lines that describe that. But then when I throw a block of cheese next to it, I'm like, oh, how do I tell? but it's very deterministic. It's all a whole series of if-then. Easy to test, right? Because if you actually do that, we should actually know what the expected outcome is. When you go to algorithms, it's a little bit evolved from that. It's really math. It's all probabilistic, right? So we kind of can look at and figure out what the outcome of that would be because it's probabilistic. It's really a math problem. And so there's that. But the hard part becomes when we're actually getting closer towards AGI, how do we test for that? It's really a behavior. And how are we going to test for behavior? We can't test the same way we test software, which is deterministic, right? Maybe evolving how we look at algorithms from a probabilistic standpoint to do something else, maybe. But this is where we're struggling. And I would submit that I think industry is thinking about it, but when I talk to industry about testing, they're like, oh, performance and drift. I'm like, no, you're missing what I'm trying to understand, because we need to understand the outcome of the behavior when we're creating AGI, so we know how it might impact a soldier's life, right? Or the decisions it may make based on what it's learned and how it's learned, and what are the parameters. So and again, when I talk about that, it's not because we want to take your IP. We don't. We are not naive enough to think that we're going to make algorithms better than industry. We're not. But we want to understand those type of things so we can understand the behaviors of that and understand how it's trained or inferenced, right? So we can understand what the outcomes of the behavior may be to make sure that we can protect lives of our soldiers. And so I don't know what that is. I would really love to have a very deep, fruitful discussion about this, because when you think about it, I don't know if again, or setting up again, to do that, to look at that, to kind of train against that, to see what the potential behaviors and outcomes may be. Maybe that's a thought there. I've been trying to think about some different approaches than your typical novel approaches, but this is where I think we need some more help, because those are the things that are going to be obstacles for us. Yes, we could put it on closed systems. Yes, we could put it on business systems. But to make the lives of our soldiers easier, or to protect them, we're going to need to know differently and think differently about how do we test behavior. Like literally, if we all have kids here, up here, the three of us, and when you think about our kids, they all learn differently. I'm a very visual person, so I'm always thinking visually. My daughter is the same way, but my son is very logical and very, so how we learn and how they learn are different. And that's the same thing. We don't know exactly how do we test from a behavior standpoint as we get close to AGI. We need y'all's big brains to help us think through that, right, to reduce some of our risk so we can get to using your algorithms a lot faster. I'm sorry, not algorithms. So we can get to AGI and consume that a lot faster.
I see your face. I know you're itching to add to this. Do you have some ideas on some of the technical approaches that we could consider as we look at testing?
Yeah. Oh yeah. So so history and software development. In the earlier days, the way we would test software was extremely structured. We would even have a discipline called software test, and we would write these test cases, and then we would have a spec. We would write the code, and then we'd have these employees essentially test software based on the test cases, and then create the find the bugs and have the developer go back. Now we've kind of expanded that, realizing that the wider and broader we can create the test cases, the faster we can iterate, and the more we can catch those kind of outliers, especially as the software is becoming much more complex, and where we put systems in much more diverse environments, which is even more difficult to test your product and your experiences. So the best way that we've found, and we've continued to evolve, is we try to build the product as fast as possible in a prototype form, and then we hand it to people mostly internal people. In Windows, we have these things called insider rings, for example, where it's not just employees but other folks that get to use the software before it's ever really made out in the world. And it's that feedback loop, that human in the loop, that essentially helps us make the system more robust, find those problems or bugs, especially in the vast array of situations that software and hardware is basically put in. And you see that also with artificial intelligence, most specifically in these large language models, that the biggest improvements that people have done in large language model improvement is in fact the testing case, putting a human in the loop to fine-tune or to give the feedback back to the neural network that, no, I really want the answer more like this. And that's called RLHF, Reinforcement Learning Human Feedback. And that's a really important loop that has really helped improve the step function in these large language models that we see today. Something related to that, but not specifically to your question, is to Mr. Bang's point about data. We have a really awesome model that we developed internally at Microsoft called Phi, and it's a small language model. I'm gonna digress a little bit. The large language models that typically run in the cloud are on the orders of hundreds of billions of parameters. And what's a parameter? Think of it as a mathematical representation. And so hundreds of billions of parameters are basically inside these models. But there's another class of model called small language models, and that is in the order of 10 billion parameters or less, so a factor of 10, maybe even 20 less. So Phi was trained not on the corpus of the internet, because that's what these large language models were trained on. And the corpus of the internet has all sorts of data, and some of it is quite junk, by the way. There's a lot of stuff that people have put on the internet that just is not good, and it's or just not very useful. And a really smart researcher at Microsoft said, what if I made the data really, really, really high quality, and I curated the data really, really well? And they wrote a paper. You can actually look it up. It's called "Textbooks is all you need." And what they did was basically generate and curate high quality data, and produce the model that blew away all small language models in terms of performance, and is able to in a lot of ways reach some of the reasoning capabilities that you see in these large language models. And it's called Phi, and it's much smaller than anyone would really expect. And it really comes down to, it's not just data, it's the quality of the data that I think matters. So a lot there, I understand, but hopefully that'll...
I want to jump in on that because for the past year and a half, everyone's been talking about large language models, and I've been saying, hey, what about the small language models? So I'm glad you brought that up, because if you think about it, and I know you have a biology background, so I tie a biology and health scenario here too, right? The large language models are doing amazing things, but it's for a general purpose, right? So if you study population health, you can generalize about the population, but it doesn't work for precision health, because the precision health is about the individual. And so in that same scenario for us, there's some goodness around large language models and about, certain things that it's already optimized for, right? Around conversation, sound logical, those type of things. But arguably, in certain other populations like biology, right, or health, the large language models aren't necessarily as good for that, because the taxonomy and the term and the data is very different. And so there's some things that you could do with large language models, but you'll have to retrain certain things for that domain. And so I think small language models is good, but that's the same thing that I would say that we need more help with y'all on small language models, because for the military and the DoD and the vernacular that we have and the taxonomy that we have, as well as some of the data sets that are very well curated, I think there could be a lot more advancements on the large language model. And for me, I'm not a binary person. I don't think it's either or. I think it's both, right? It's a hybrid model that I think that always tends to work better, but right now I think we have so much focus on large language model and not enough on the small language models. I think that would be a great opportunity for industry to help us.
And the beauty of the small language models is that they can run on your device, and so you can have that. You can have that sort of reasoning ability and power right there in your system. Now, cool enough though, like the large language models actually do contain all that information. What makes it difficult is how do you pull it out? How do you extract that? And this, people have probably heard of prompt engineering, in recent years. And prompt engineering is basically a technique to try to extract the reasoning abilities and information that are stored in these really large models. And that's now shifted from prompt engineering to what we call fine-tuning, which is what Mr. Bang was alluding to, which is kind of a form of retraining the model. You don't retrain the entire model, but you adapt it on just the initial layers to make it easier for you to get at the specific domain that you're after in there. So if it's legal or health or just specifically for your business. And so we even, in Microsoft, you have the ability to take a large language model like GPT and in fact adapt it to your specific application. And now it's much better for your specific task because you've told the model, I'm interested in this and not all the other stuff, so that reduces the probability that you're going to get a wrong answer.
Thank you. I am going to ask one last question, and then I'm going to turn it over for audience Q&A. So if you've got anything on your mind, please feel free. So my last question is, with you guys all up here, Troy and Young, what is it that you guys really want to see from industry, from academia partners, and even within government to try to do all of the things that we've talked about today? It's a lot. And then same question for you, Stevie, on the flip side is what do you need to see from your industry partners and also from Army and government to try to get to all the things that we really need to and want to do? So Troy, I'll start with you.
Yeah, I appreciate that. I think, this is a super valuable question, actually. I think I'll start with a message first. So the Army, your Army, is serious about understanding this environment and adopting these capabilities. And we want to do it in a meaningful and ethical way. With that, the understanding of there are numerous different companies, small, medium, large, that are in this space that have really, really good ideas. So that's point one. So we recognize that. Point two would be on this journey, the communication from the Army to industry is increasingly important. What do effectively our roadmaps look like in terms of what we think we need when? And then it's the conversation that we need to have and continue to have. And when I talk to industry and interact with industry, what I ask them is, tell me if I'm behind the duck, if I'm on the duck, or am I ahead of the duck, right? Am I setting my expectations too low? Am I about right? Or am I my expectations way exceeding where technology is? That candid conversation is super important. And I will say, in my career, I've had a little mixture of both across industry where I'm a big believer in under-promise, over-deliver. That's a good philosophy. Sometimes we want to say yes so badly because we want to partner that we lose that candid conversation. We're like, yeah, we think we can figure it out as long as 27 miracles happen between now and next week. And that's the conversation that we need to have. So we're all set up for success. And then recognize that many of you are smarter than a lot of your buyers, so help educate us too. That we're starting, there's there is a campaign in the Army to better educate along data and some of these capabilities, but that's not completely pervasive too. So that's another, I would say, ask. And I think I'll pause there.
I would say, like, communications, and I always use the term, meet us in the middle, right? So I think y'all can see that the Army's not your grandfather's Army. We have some pretty technical folks that understand this, are driving transformation differently. Come and talk to us. The communication will be very transparent, and that's the only way I have. So if you don't want to know an answer to the question, don't ask me, because I will tell you the truth. But in the same context, we expect the same thing from your side. If we don't know something, tell us. Be like, or that's so, like Troy said, that's so unrealistic now, but maybe 5 years. Whatever that is, but meet us in the middle. What we want to do is really push the envelope with industry, with technology, get things done faster. And it's okay. It's about innovations. It's about failing quickly. We don't want to have programs that go on for 10 years and all of a sudden, oh, we got to kill it because it's not going to be there. Okay, let's work and iterate faster and faster and faster. We're going to learn from our mistakes, but as long as we do that, we can course correct along the way. If we just kind of go on this path and like Troy said, we have 100 different miracles that have to happen for this to go, we're never going to get there. But again, if we meet in the middle, right, y'all be transparent with us, be open about communications. We'll be the same way. Y'all can come and talk to me in the building anytime you want. And oh, by the way, please don't dress up if you're coming to see me in the Pentagon. This is literally what I wear, sneakers, jeans, and shirts, okay? But it really, if
I do not wear this every day, for the record. Okay.
But the other thing too is like, come to us with a little bit of, we'll help you understand the government or the Army or contracting. I know that's a frustration. We're working on things to bridge the valley of death. But I would also say, meet us in the middle. Do a little homework on what our business is or what our missions are, right? And so don't give us a better mousetrap, or don't say, I have this cool tech and it's innovation. Apply that innovation to our business and our mission and help us revolutionize the way we think about it. That is innovation. Don't come to us with a better mousetrap. Apply it to our mission and help us evolve it together.
Yeah, I mean, and on the heels of that, I think the viewpoint of industry with the government or Army is that first the opportunity, because the diversity of the class of the problem combined with the specificity of the problem is what breeds innovation. So opportunity is really key, and so I think, you know, this sort of culture and system that you folks are set up is really, I think, quite powerful because of that. You enable the opportunity for other people to help innovate. So I think the innovation, enabling the innovation there is key, and I think the government and the military has had a massive history of enabling that and spearheading innovation as a result of trying to solve really hard problems in really difficult situations, and that's made it out to the public, that's made it out to the industry, it's saved many, many, many lives. So I would say like that's one class, and the second, going back to my point about moving complexity around, kind of the ask, and I think already happening, is it's not just, you know, a hard spec and you must do this and it has to work this way. It is looking at the problem holistically, what's possible, and then moving complexity around so you can develop the best product. Best product for your application, best product that can be done for the industry. And I think it's that sort of relationship where you know, you literally have just, you know, you put together product makers in a room, you know, from all the different disciplines, and you say, don't come out until you have something that actually makes sense. Not just because this is a hard requirement, but because you can have the flexibility to move requirements around so that you can actually make something happen.
Awesome. Thank you guys so much. We have questions. Fantastic.
Yeah, hi. Thanks for the informative talk. My name is David Fuller. I'm the former CTO of the Cuckoo Group, the fourth largest robot company on the planet. I founded a company called Artificial. So a lot of what you talk about resonates with me. My question is, you talk about abstraction, you talk about connecting AIs to action. In order to make that really work, you tend to have some sort of model of the world that you're trying to interact with. Do you guys know what is your important curated data, and do you have underlying world models for connecting the AIs to some sort of semantic action?
That's a super great question. And so I'll try to answer some of that. So we don't have that yet. We have pieces, and we have pieces of very curated data sets around very specific things. So to the point that Stevie was making, we don't want to recreate a virtual world where y'all have better data and information than we do. But we want to really focus on those areas that are very special for us, for our needs, and then consume what you have as well and create that digital experience. And for us, you will see we've been talking about a digital engineering strategy for the Army for a while. You will probably see in the next month a policy really codifying that digital engineering strategy. And that's an attempt to get us out of the paper world more into the digital world. Whether we can actually consume models and other things, we're going to actually have to ask industry to help us. But what we want to do is set up a strategy and environment where we can pull those pieces together, leveraging what y'all already have, using curated data sets for very specific things that we might have. And trust us, we have some amazing physics-based models on certain things that we will work with y'all. But there are, in our minds, they're not commodity quite yet, but things that y'all were going to do anyways that we don't want to recreate, right? And so it's really a partnership to create this environment where you bring what you have, kind of meet in the middle. We'll bring what we have. We have to get through a little bit of a thing called interoperability, right, to do there. But that is our goal, to create something like that. From a digital engineering standpoint, there's another effort called Project Linchpin that we're really driving the infrastructure for artificial intelligence and a trusted environment with data sets that we want to share with the community. And so those are all pieces of that broader strategy. We're not quite there, so work with us. But if you have great ideas along that path, we're happy to listen and work together.
And the only thing that I was like counting off the things that came to mind, and the only other thing that came to mind to me was, and it's kind of meeting in the middle, understanding that if you think about robots and their application for the U.S. Army, it'll be in an environment that is dynamic and constantly changing. So that's probably the gap area that would be a really interesting conversation that we're starting to have with folks. Like, okay, given that the environment changes every second, what level of fidelity do we need, and how do we continue to learn as we go, if you will? Does that make sense? Okay.
Thank you for sharing your thoughts and considerations today. It's been an incredible talk. I wonder, moving complexity around, might it be tempting to move too much to the machine or its self-control? So, understanding the U.S. military, DoD, as an ethics-centric organization, what ethical controls do you believe need to be baked in, especially as AI moves from the artificial side of code to outcome-based use cases with intelligence?
So I'll jump on this one initially. So first, everything that we do revolving around AI is governed by a policy that was signed out. Don't make me quote the exact date and year because I'm having a moment right now, but a few years ago. And really in that policy, it specifies that there is a human involved somewhere in that process, so that machines, the Skynet of the future that everybody's worried about, we are equally worried about. And I think that's one I want to be really clear with. So there is always going to be a human. And as I mentioned up front, one of the biggest considerations that my boss, General Rainey, has told me as we talk about this is we are optimizing for what robots are good at, or machines and humans. Judgment, ethics, following the law of armed conflict that we are all signers of, are human activities. And we don't see a world where we replace that, recognizing that we've got to put safeguards on. But I think what I'm trying to impart here is we recognize that, and we're doing that deliberately along this journey so that we don't give control to robots again, so the humans aren't working for robots are working for humans.
I mean, to add to that, absolutely. In that stack, first, beautifully worded question. Thank you for that. In the stack of moving complexity around is, in fact, a pillar or a component of what we call a responsible AI. And it is indeed a requirement, in a lot of cases, a hard requirement when you're designing a system and a product there. At Microsoft, we have an entire process dedicated around responsible AI that is end-to-end the life cycle of artificial intelligence, from the data curation and making sure that the security and the outcomes of the product is exactly where we want it to be. And indeed, if it doesn't meet those requirements, you don't put it there. You move it around. So I would say that's
Yeah, I want to build on both of those. So I think Troy's right. There's a policy that DoD signed years ago talking about a human in the loop, right, to make sure that there's that component. The other component that Stevie said about responsible AI, actually DoD has been one of the first organizations to publish that. We have a framework around responsible AI as well as ethics around AI. You can decompose those components in there as well, so that ensures that there's a human in the loop for that process. And it really, I kind of akin it to what in the military we call the art and science of leadership. There's always an art dimension of that based on experience, or the human component of that, and there's always a science component of that. And I think we do a good job of really making sure that we focus on the human in the loop with the framework to ensure things that are really repetitive, mundane tasks, right, that you can do from an automation or an orchestration standpoint. We want to accelerate all of that. And what we want to do is really enable AI to enable people to do the things that they excel at, which is really around the art components of that. So we're not going to really automate everything from a decision standpoint, but what we're going to do is automate insights to inform leaders so they can make those conscious efforts to decide what they're going to do next. So we do a pretty, I think, a pretty good job articulating that, and it is codified in policy as well as a framework within DoD.
Good morning, everyone. My name is Sergio. I'm a cybersecurity architect for the Department of Defense and prior Army. And I'm a developer working on AI solutions. And I just had some questions, kind of a two-part question about technology. So you had mentioned LLMs versus small language models, and you had given some parameters. Do you have any examples, for instance, of, say, like popular or trending small language models?
Yeah, I mean, the one that we just put out there called Phi is an example. There's a number of them out there. One is from Facebook. Name escapes me at this moment. Google has one they called Nano, for example, and in a lot of cases, the language model there, the small language model, initially was to try to maybe do some of the reasoning abilities in a situation where you wouldn't have access to the large language model, or it was cost prohibitive, but at a quality that was far, far less. And with the recent work that we've done in the company, we're slowly showing that you can indeed get some pretty amazing results out of these small language models, and especially if you can curate the data set and train the model and apply some novel architecture to it for the most part.
So thank you very much. So the second part of my question actually has to do with the application of the small language model, or even a large language model.
Yeah.
One of the things, there's a basic assumption that they're going to be trained fundamentally from the ground up, potentially, on this specialized data that the DoD or that the federal government has. But what I'm curious about is the application of using them as an abstraction layer to specialized data. So confining the responses and the repository of knowledge to these specialized use cases, it seems to me like that's a fundamentally better architecture. And I wonder if you could compare that to retraining.
Yeah, I mean, I don't know yet if it's better, because you have to take into context how the customer is using and what prompt they're going to put into the system. It could be a quite complex prompt or a high-level prompt there, where a fine-tuned version of a GPT might handle that better. In other applications, you may not have access to a large language model, and you might have to just have a small language model do the work. I don't think that's like an either-or situation, like one's better than the other. It depends on the situation, and both have their applications, and both are, a great tool to help solve problems. And small language models, in a lot of ways, because they're not as currently not as accurate as the large language models, are sometimes used in kind of like in an internal algorithmic loop, rather than have it be a customer-facing sort of technology.
Gotcha. Oh, thank you very much.
Hey, actually, I want to jump on some of that. So I love the question because I think Stevie's right. I don't think we know, right? So we need your help to help us really test out some hypotheses. And again, my assumption is it's probably both. It's probably a hybrid model that works. And since you come from the cyber side, we are working, at least on the Army side, on some policies to do a couple things. One, reinforce all the existing policies around data and what can and can't be shared, so that we can actually get industry and our Army to really experiment more with large and small language models. So you'll see that coming out, but it just, again, reinforces what you can and can't do with what type of data. But we're doing that because we want you guys to work with us to figure this out. And I think it goes back to what Steve was saying. It really depends on the scenario and use case. And the same thing right now, there's a certain model that a lot of large language model companies are pushing, and in a lot of ways, the Army can use that model to a certain degree in certain use cases, but we can't in other use cases. And so in those scenarios, we might have to use a small language model, but I do think that there are scenarios where we're going to have to do a hybrid approach, and we need industry to help us figure that out.
Yeah. And just like my last thought on that too is, as you might imagine, there may be a situation for the Army where we don't have access to the cloud.
Sure. Yeah, absolutely.
And so that
That's
use case is kind of interesting,
assumption.
right?
Yeah, that we would be disconnected.
Yes.
I know we're at time, guys. So I know you've been standing in that line. So I'm just gonna.
Well, we got one more.
Yes,
Will we let him ask his question?
I want to
Okay.
make sure he gets to ask,
Okay.
as long as it's okay with you guys. And I also want to just remind everybody that there is time after this session. There's another session focused on AI where small business enters the chat, and then we'll have a reception right out here where you can talk to all of the panelists from the multiple sessions and get your additional questions answered. So, sir, please go ahead.
Hey, my name's Bear. I'm a graduate student at UC Berkeley doing machine learning and robotics. My question is for Steven, and it's basically like, what does this look like within your team, doing research and product development that matches what are really unique constraints of the Army's procurement process? How is that changing your team dynamics, particularly versus other customers you might be working with?
It's a great question, great school. I would say that one of the kind of philosophies that we have that has evolved kind of goes back to one of my other points about moving complex data around. You can't move it around if you don't understand the entire stack. So you really need to build a multidisciplinary team that understands and are experts in each of the layers. And once you're able to do that, you're able to look at the problem holistically and solve it holistically, which is really important. If you only have a team that is really good at this specific part, you're only going to be able to make this part great. But you miss the rest of the opportunity in the stack. So being multidisciplinary, it's nice that you're in the field of robotics and AI, because that is actually by its nature quite multidisciplinary, which is pretty cool. So I studied also robotics a little bit as a grad school, and I was really keen on trying to study as many different topics and subjects as possible. So I encourage you to continue doing that, because that's how you're going to be able to solve the problem in the best way possible.
Hey, this has nothing to do with your question, but if you don't mind, I got a little story since you're at Berkeley, right? And it's a little bit about this, right? So a lot of people don't know a lot of the great work that the Army's been doing in this space. And we've actually partnered with Berkeley and Lawrence Livermore out there, right? For all the compute that you have out there. Amazing. If y'all haven't gone to see some of the stuff that's out there, it's really cool. But one of the things that we did with Lawrence Livermore in Berkeley was we worked on, does everyone remember this little thing called COVID, right? And when that first came out, the vaccine and creating a vaccine for that was extremely hard until we actually figured that out. But like the second and third generations of the variants of COVID was really easy to address because it was just a simple variation of the vaccine. But when Corona came out, that was hugely impactful because none of our previous vaccine made a dent on that. And so the reason I tell the story is like the Army, and you would think it's HHS or something, the Army actually worked with Lawrence Livermore to create generative models that did a couple things. And the way that we took it was a multidisciplinary approach. It wasn't just people that knew healthcare or people that knew AI or any of those things. It was a multidisciplinary approach that really looked at a couple things. How do we create a generative, a Gen AI model that looks at all the variations of vaccines? But more importantly, we looked at how can we optimize that to look at what combinations of that really optimizes the bonding. And so when you look at that approach, it sounds kind of obvious when you talk about it, but it wasn't when you were actually doing it. And that's what was really hard. But what we were able to do when we looked at that, we were actually able to optimize both of those things. So we actually were able to find a vaccine in 2 months, right? So y'all remember when it came out and we actually came out with a vaccine. It was not HHS, it wasn't, Merck or any of those by themselves. It was the Army working with Berkeley and Livermore to really figure out that vaccine. And we had that rolled out to the country, right, really quickly in January. And if you think about that, people don't know. Everyone hears about Project Warp Speed and all that type of stuff. It was the Army that bought all the vaccines, that did all the procurements, that sent it out across the country, right? But again, building on that, it was really our ability to look at a multidisciplinary team, multi-party team with academia and industry to really get at that type of thing. And it was actually all Gen AI before Gen AI was pretty cool.
All right, excellent panel, awesome audience. Thank you all, and more to come.